Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 4, which is about triangles. This lesson is called Use Isosceles and Equilateral Triangles. Our essential question is, how can we use the characteristics of isosceles and equilateral triangles to solve problems? All right, so we have a warm-up here. It says solve for x. We have a special type of triangle here, but what do we know about the angles of the interior angles of a triangle? They all add up to what? Yeah, they all add up to 180. So why don't you guys go ahead and see if you can solve for x. Go ahead. All right, so let's go ahead here. We're going to add up the angles here. So we have x plus 69 plus 42 equals 180. All right, combine like terms here. We get x plus 111 equals 180. How do we solve for x now? Subtract 111. We get x equals, it's going to be 69 degrees. Now, what do you notice about that answer here? Well, it's the same. These are equal right here, okay? And this is a what kind of triangle? It's got two tick marks here. What kind of triangle is that? It's an isosceles triangle, which means it has two congruent sides. And so if you see, the angles across from the congruent sides are going to be the same, which is a characteristic of isosceles triangles. So very cool. All right, let's get into this here. Let's draw a triangle, and we're going to go ahead and, let's actually draw it up and down. We drew it sideways in the notes, but I think it'll be better to draw it up and down. So I'm gonna do my best to draw an isosceles triangle here. It's not gonna be perfect, but it'll get the job done. Okay, so these are here. Okay, so the legs of an isosceles triangle are the two congruent sides. The two what? Two congruent sides. So these are the legs right here, okay, of an isosceles triangle. Okay, the vertex angle is in blue here, and it is the angle formed by the legs. So this is going to be the vertex angle right here, okay. All right, the base of a isosceles triangle is going to be the side of an isosceles triangle opposite to the vertex angle. Opposite, so it's going to be, this is the base. I guess I should label this. This is the base. I'll put leg. Oops. Leg. Leg. Okay. And then, oops, what happened here? That's not what I want. Okay, and then the last thing we have are base angles, okay? And those are the two angles that are adjacent. What does adjacent mean? Adjacent means next to. They're next to the base of an isosceles triangle. So these are going to be base angles right here, okay? Those are base angles, okay? So yeah, so that's going to be our, make sure you take a minute and pause this if you need to, but those are kind of the important markers of an isosceles triangle. Okay, let's move on here. So what do we know about base angles theorem? So if it's an isosceles triangle and the sides are congruent, the angles opposite them are congruent, okay? So angle B is congruent to angle C. All right, and the converse is also true. You can, if the base angles are congruent, then the legs are also congruent, or the sides opposite them are also congruent. So remember, we'll go like this here. These are congruent, okay? So AB is congruent to AC. All right, and a corollary. It's kind of similar to, this is for equilateral triangles or equiangular triangles. If a triangle is equilateral, then it is also equiangular, okay? The angles are also congruent. And by the corollary, the converse is also true. If it's equiangular, then it is equilateral. Okay? All right, so we're going to do a couple examples together, and you guys are going to try a few. So let's do this here. All right, so we have this triangle here, for example, when we're solving for the missing variables, which is x. So what are these angles right here? Sometimes we're going to be looking for the base angle. Sometimes we're going to be looking for the vertex angles. What are these? These are base angles, and are base angles congruent or something different? They are congruent, so we're going to set them equal, right? Because they're across from the legs, right? So 5x equals 55. How do we solve for x now? Divide by 5. We get x equals 11 degrees. All right, let's do one more. Okay. Number 2, we have x plus 5, we have 47, and y. And we actually need to solve for x and y here. Okay. Normally, unless you know like 2 of the angles with no variables in a triangle, you're going to need to use something different here. So we have 2 of these angles have variables in them, so we can't actually do that. So we're going to need to use the base angles here. What are the base angles of this isosceles triangle here? It's these 2, right? So we have x plus 5. Oops. X plus 5 equals 47. How do we solve for x now? We subtract 5. So x equals 42. So we have x. So now we know both these angles here are 47 degrees, right? Because they have to be the same. How do we solve for y now? Well, we can add them all up to 180, right? So y plus 47 plus 47 equals 180. You could do 2 times 47 if you wanted to save some time. So 2 times 47 is going to be 94 equals 180. Subtract 94. Get y equals, that's going to be 86 degrees. All right, so sometimes you can solve for the vertex angle, sometimes the base angles. I would say the base angles are probably the first thing you want to solve. But yeah, why don't you guys go ahead and try these checkpoints now, see how you do. Okay, here we go. So what do we have here? These are isosceles triangles again. So we know the base angles are congruent. What are the base angles? 9x is equal to 54. So if we divide by 9, get x equals 6. And we know that all the angles inside are going to add up to 180. So we can do y plus, these are both 54. So 2 times 54 equals 180. So y plus 108 equals 180. Subtract 108. Y equals, that's going to be 72. All right. A couple more here. What are we going to do here? This is an isosceles triangle again. So what are we going to solve? The base angles are congruent. So we're going to do 5x equals 55. Divide by 5. X equals 11. All right. Now how do we solve for y? Well, y plus the 2 base angles, which are 50. Oops, not equals. Plus 2 times 55 equals 180. 55 times 2 is 110. Subtract 110. Y equals 70. All right, sounds good. Okay, last one here. What do we have? The base angles are down here. We have 8x equals 80. How do you solve for x? Divide by 8. X equals 10 degrees. All right. And then we got to solve for y. Well, we know y plus 2 times 80. The base angles are 80 equals 180. 2 times 80 is 160. Subtract 160. And y is going to be equal to 20 degrees. All right, that should be all I have for you today. Thank you for watching. Have a great day, and we will talk soon.